Finding the coefficients of a quadratic polynomial given 3 points. First, a note about clear reviewing when watching a video on TikTok. You might notice that when you watch a video, you have a list of items down the right-hand side of the screen and other things that come up that may interfere with viewing. If you long press on the screen, this menu will come up. At the top of the menu, this option, Clear Display, will remove all of that, which may make it easier to view certain things. First of all, definitions. Quadratic is a polynomial of degree 2. It is a summation of terms in one variable. The highest power of the variable is 2. The most general form is given by ax squared plus bx plus c, where a, b, and c are constants. Examples of this are y equals 2x squared plus 3x plus 5, y equals x squared plus 2x plus 1, where the coefficient of x squared is 1, and y equals x squared minus 1, where here the coefficient of the x term is 0, hence it disappears, and the constant is minus 1. Problem 1. Find the coefficients of y equals ax squared plus bx plus c such that it passes through the points 2, 5, 3, 12, and minus 1, minus 4. Step 1 is substitution. We will substitute each of those coordinates into the equation. So when x is 2, y is 5. That's what the first coordinate says. X squared will be 4. So we have 4a plus 2b plus c is equal to y, which is 5. That's equation 1. Let's substitute the second coordinate into the equation. X is 3, y is 12. Ax squared becomes 9a plus bx, which is 3x plus c is equal to y, which is 12. So we have 9a plus 3b plus c equals 12. Let's call that equation 2. Now substitute the last coordinate into the equation. So when x is minus 1, y is minus 4. That gives us a minus b plus c is equal to minus 4. Let's call that equation 3. Step 2, elimination. We have 3 equations and 3 variables. Let's eliminate one of the variables. If we subtract equation 3 from equation 1, we end up with 3a plus 3b is equal to 9. We can divide that through by 3 to get a plus b is equal to 3. Now, if we subtract equation 3 from equation 2, we end up with 8a plus 4b is equal to 16. We can divide through by 4. 2a plus b is equal to 4. Let's call those equations number 4 and number 5. If we subtract equation 4 from equation 5, we end up with simply 2a minus a, which is a. The b's cancel out. 4 minus 3, which is 1, giving us a is equal to 1. We can substitute that into equation 4, the simplest one, and we get 1 plus b is equal to 3. B must be equal to 2. Now we can substitute those a and b values into any of our equations to find out what c is. Into equation number 3, we get a minus b plus c, which is 1 minus 2 plus c is minus 4. So that's minus 1 plus c is equal to minus 4. C must equal minus 3. In the previous slide, the problem was finding the coefficients of y equals ax squared plus bx plus c such that it passed through those 3 points, 2, 5, 3, 12, and minus 1, minus 4. Well, we worked out a is 1, b is 2, and c is minus 3. That leads us to the quadratic y equals x squared plus 2x minus 3. Here's the confirmation. Y is equal to x squared plus 2x minus 3. We can see the quadratic there, the parabola, and indeed those 3 points are on that curve. Problem 2. Find the coefficients of y equals ax squared plus bx plus c such that it passes through the points 1, 8, minus 1, 2, and 2, 14. Step 1. Substitution. Substituting that first coordinate 1, 8 into the equation, we get a plus b plus c is equal to 8. Substituting the second coordinate, minus 1, 2, into the equation, we get a minus b plus c is equal to 2. Substituting the third coordinate, 2, 14, into the equation, we get 4a plus 2b plus c is equal to 14. Let's call those equations respectively equation 1, equation 2, and equation 3. First step, let's eliminate a variable, so let's add equations 1 and 2. That gives us 2a plus 2c is equal to 10. Let's divide 3 by 2. A plus c equals 5. Let's call that equation 4. Now we need another equation with just the variables a and c. So let's subtract 2 lots of equation 1 from equation 3. 4a minus 2a, which is just 2a, 2b minus 2b, 0, and c minus 2c minus c. So what that gives us is 2a minus c is equal to minus 2. The minus 2 comes from 14 minus 2 times 8. Let's call that equation 5. 2a minus c equals minus 2. Adding equation 4 and 5, 3a is equal to 3, which means a is equal to 1. Let's put that in the box. Substituting that into equation 4, 1 plus c is equal to 5. That means c is equal to 4. Let's put that in the box. Substituting that back into equation 1 gives us 1 plus b plus 4 is equal to 8. b is equal to 3. Let's put that in the box. Those are our coefficients. So from the previous slide, we saw that substituting the points 1, 8, minus 1, 2, and 2, 14 gave us the coefficients. A equals 1, B equals 3, C equals 4. So our quadratic is y is equal to x squared plus 3x plus 4. Once again, here's the confirmation with this parabola. Here's the curve y equals x squared plus 3x plus 4. And again, those 3 points lie on the curve. Summary. When we have y is equal to ax squared plus bx plus c and we're given 3 coordinates and asked to solve for the coefficients, what do? Step 1. Substitute the x and y values from each coordinate into the general form above to get 3 equations. Step 2. Look for a pair of equations that will allow easy elimination of one of the 3 coefficients, a or b or c. After doing this, find another pair. We have 3 ways of choosing a pair from them. Eliminate the same coefficient as above so that we now have 2 equations and 2 variables and solve. Step 3. Now with 2 variables solved, plug these into any of the original 3 equations and solve the 3rd variable.